Oh. Number one, it's February 22nd. It's Tuesday. Lots of twos. All right, so yeah, I didn't do this yesterday, so let's make up for it. The first problem is Excel sheet column number. I remember this problem, and it gave me a lot of trouble last time. I might even put this into a list. Probably not. No, I didn't put it in the list. Yeah, I don't think I did well on this. Okay, so yeah, the idea is simple. You're given a column title that represents the column, return the corresponding column number, yeah. So 1 to Z, and then we get Z26, and that's AA. Okay, AAAB all the way to AZ, and I think it's BA, right? And then CA all the way to ZA. How is ZZ after ZZ? After ZZ is AAA. Yeah. After ZZ is AAA. So what we know is yeah, A is 1, this is AB, right? Because it's 2, right, and then it's A, that means if it's A something, that means we have gone through 26, right? We've gone through 26, and then remaining is B. I mean, A something is 1 times 26, right? B something is 2 times 26, all right? And then the remaining is just the remainder. Okay, ZY. So I say if it's Z, that should be 26 times 26 plus Y. Y, X, Y, Z, that should be 25, right? So my current theory says it's going to be 26 times 26 plus 25. 701. Maybe I'm onto something. How about 3 levels? Well, 3 levels say AA something, right? It's the same thing. The first A just means it's 26 to the 3 minus 1 power, right? Yeah, that's, come on. This is just not like binary, it's like 26th-nary value. So it's just, we do A to Z, that represents value, times 26 times something. Okay, so what do? We will, same thing here. Yeah. It doesn't seem to be that hard this time. Maybe I remember wrong. But I remember last time I had lots of trouble with this. Now, think of it as just a binary system, but instead of binary, it's we have 26. The radix is 26, right? Okay, so what do we want? We're gonna go from back to front, right? From back to front. So what do we say is res equals 0 for I in range, say len, column title -1. Might as well, you just, how long is this one? 7, right? 7. So for A in column title, I'm just reverse it. All right. So we reverse it for every one. We say res. Oh, we also use I. Enumerate it. Okay. Then why do you use res? Yeah, we don't have to use res. We're just gonna be ord a minus, I think it's 65. I think it's 65. Let's see. We want to find is ord a, ord capitalized A. Yeah, 65. All right, so minus 65. Oh, minus 64. All right, so that is the value multiplied by 26 to, multiply by 26 to the I minus 1 power. And then we do a sum. So we return sum of this whole thing. Okay, so run some test case. So A shall be 1. AB is 28, we know that. And ZY is 701. This is column. This is a title to number column. What is this? Wait, what happened? Huh? hold on, hold on. It's not what I had expected. It's in numerate, right? So that should be 0. Oh, that's not minus 1. That should just be I. There we go. Ah, I got a little bit issue over there. All right, let's run some test case. Let's run this one. All right, this is the largest one. That's allowed. Okay, run it. Yeah, I think that's it. It's not too bad. Same. Wow, it's 599 days there. Tomorrow's gonna be 600. All right, so this is. But why do I think this one is difficult? I don't know. It's actually not that hard. 171. This is as if the column title is a numbering system with base 26. When 30, I think 38, right? 38, 37, 68. Yeah, okay. That shall be it. I don't think it will be any difference from the other one I do. Yep, it's the same thing. Okay, done with this one. And move on to this. You're given a zero-indexed array of positive integers where this describes the weight of the ith index. You need to implement the function pickIndex, which randomly picks an index in the range this to this inclusive and returns it. The probability of picking an index I is wi divided by sum w. For example, if it's 1, 3, the probability of index 0 is 1 over 4, and probability. Yeah, that's 1, 3. I will return the index. Okay, so basically it's just so what should we do? We have those indices, right? And then we say have 10% chance will be this, 20% chance will be this, 20% chance will be this, and then be like this. So when I roll a dice, or we can do just random 0 to 1, right? If the value, we get a value, then that represents, like if we roll a point 2, what does that mean? I used to know what it means. So that's smaller than, yeah, if I roll a point 2, right? So with the chance of 50%, right? So the 50% of the chance will roll a number smaller than this, right? If it's 60, 60%. So when I roll a value, then it will fit, like say 0.5, 0.6, right? So that's within this chance. So what I do, if I say I have a value, 30% of the chance it's going to be this one, and 70% chance will be this one. Or we just use the example 25 and 75. So I roll a dice. If it's larger than 25, so we pick the other one. If it's smaller than 25, we'll pick the first one, right? Yeah, or what if we have 3 values? Now we have 3 values. Let's say we have 20 chance for the first one, 40% chance for the second one, no, 30% chance for the second one, and 50% for the last one. And then roll a value, right? And then if we order them, right? So 0.2, 0.3, and 0.5. I'm going to roll a value. And so for roll a value, and if it's smaller than 0.2, because I have 20% chance to be between 0, 1 and 0, 2, or 20% chance, and then 0 to 0, 3, that's, so do we always roll multiple times? I rolled it once, and yeah, I'd say I rolled it once, and it's, what if it's larger than 0.5? Then we don't choose any of these. Because I say I have a 50% chance we'll choose this. But hold on. Everything add up will be 1, right? So if I say I have 20% of chance to be in this index, 30% chance to be in this index, and 50% chance to be in this index, they add up to 100. So if a value is landing in between the demarcations, and that should belong to that one. Okay, all right. So what do? We create an array, right? We create an array 0.2, 0.3, and 0.5, right? We create an array 0.2 was actually 0, 0, 0.2, 0.3, 0.5, and 1. Right? That's our array. And then we roll a value and intervals, right? So 0 to 0.2, that's an interval. 0.2 to 0.3, that's an interval. 0.3 to 0.5, that's an interval. And then 0.5 to 1, that's an interval. But that, how many values are we looking at? Now 30% is now it's 0.5. My bad. No. It's cumulative. It's cumulative. So 0.2, 0.5, and 1. So 0 to 0.2, that's one interval. 0.2 to 0.5, that's another interval. 0.5 to 1, that's another interval. So when we get a value, we binary search it, so we know which position to end up, and then that region will be the selected value. So if we say 0, 1, 2, 3, and how do we represent the index? Oh, it doesn't matter. It doesn't matter. We can just, yeah, it doesn't matter. We don't have to order it because it's cumulative. It doesn't really matter, right? So the first one will just be 0, right? This will be 0. So whatever I'm landing here, right, will be 0. So minus 1. I'm landing here, minus 1. Landing here, minus 1. Okay, we have a solution. Thanks. 8. No. We don't have to use reservoir sampling. I thought it might need reservoir sampling. Anyway, so self.w equals w, right? And what else do we need? What we need is a cumulative sum. So self dot presum equals presum equals list accumulate. Accumulate. Hold up. We can do better. Let's say from into tools import accumulate, right? So we have this. We actually don't need a w anymore. I can just do presum, and it's gonna be this. I say s equal to sum w, right? And then this is gonna equal to for p as presum or p in accumulate w, right? And every one we're gonna say p divided by w and make this into a list. P divided by w? No, p divided by s. Okay, and then we do binary search and random. So from bisect import bisect right, and from random import random. Then what do? We say vr equals random, right? I think random is 0 to 1. Let's try. Say from random import random, and then we call random. Yeah. So r is random, and then we're gonna return bisect right self dot presum random. I don't have to do this. And this one will give an index, and index minus 1. That is my solution. Let's see if it works. Console use example. Random. Bisect module is not callable. Huh? I don't know what happened there. Can I do it right? Holy guacamole, I forgot a 0. Shoot. How long is this? 10 to the 4, 10 to the 4th. Okay. 10 to the 4th. Okay. This might be slow though. That's ON. That's also, yeah, ON. Let's try it. Pretty good. I did pretty well. So solution produce a cumulative probability function. No, density function, CDF, for each index by finding the prefix sum, and divide it by the total sum. Then we can randomly produce a value between 0 and 1 and binary search it in the CDF array. The range where the random value lands is the index selected. So ON for initialization, and O log n for pick index. Yep. Okay, let's take a look. Oh, 185 and 97. Ooh, 185, 97% ranking. Right, I see some. This is the prefix sum, binary search. Yep. Yeah, we hit the right one. 01. How'd you do 01? Alright, this one deserves a detailed read. Single priori already know linear search, binary search. O1 of pick. I create 4 boxes with size. Box 1, 0.1 of W1, 0.15 of W3, box 2, 0.2 of W. can understand. Alias method. These are the values, right? And let's create 4 boxes with size 0.25 and distribute original weights into. So this is our computer weights, yes. So we have 0.1 of W1 and 0.15 of W3, 0.2 of W2. So what are these things? There's ATCG here. Nah, I think just follow this. So first the box. 0.1 of W1 and 0.15 of W3. Sum was 0.2 and 0.05, 0.1 and 0.15, 0.25. This is always the way to distribute weights. Proof and addition is always with one box with weight smaller or equal to, and a one with larger or equal to. Yeah, I mean, these are equal, so we can just take one and put in another one, so it will be first box in full, now the rest of weight from the second, so they fill the full box. Take 0.1 minus full W1 and we have this. Again, we can have one box. Create ununiform boxes of size. Fill them with at most 2 indices. And it's weight associated with the first index. Fill them with at most 2 indices. At most 2. So I can fill the first one, right, with whatever. And then if it's not enough, I can fill with the second one. And because it's 1 divided by n. What if we need a third one? I get the weights, get the size of bigger weights and the small weights. That's the average size. Okay, so we have the bigger size and small size. So we will always pick big or small. So I pick the small, put it into the box. Pick a small and a big to make a full box. Box.append J I. Hold on. I is the big weights. I is the big weights and I is the index. There's the index and a weight. So we put the small in it and put the large. So we only record the small one. Okay? Because it's larger than, it's smaller than. So if we pick the small, and we always put some of the large. Okay, that makes sense. And bigger weights minus this. Big weights is smaller than size minus epsilon. Basically just the big weights is smaller than size. Then small weights I, small weights I equals big weights dot pop I. What is this? That becomes small. Why I also handle I? What if I has a value? Oh, I and J. Oh, these two are different. These two are different because it's big. This I and these two I are different. So okay, that's fine. So try to fill all the boxes. Right? Fill all the boxes. And once we fill, the remaining will be the big weights. Okay. So we just put the small weights down, right? Because they're small weights, so we can always find some big weights. Doesn't matter. We find some big weights to fill, right? And eventually, the big weights will all filled up, and then okay. So pick a random box. If it's 2, we'll pick according to relative weight between the two. So I pick a box. If this, I return this. Otherwise, I pick another random. If it's larger or equal to the weights. If it's larger than the weights, I return 1. Smaller than the weights, I return 0. And the weights associated with 1. So it's larger, we return 1. Okay, I see how this one is. Why does it work? Well, we randomly pick, okay? And what we're saying is like the makeup of these two, these two, these two. Each box has a random chance of being picked, right? And within each box we have, yeah, that does make sense. Yeah, I think it's the way that you choose. Yeah. Huh. All right, I don't think I'll implement this, but it's interesting. Interesting method. All right, I'll be it. I will see you guys later tonight. Adios.